Hi everyone, this is Sana Almas, and my research is developing and FCR methods for the chemometric analysis of organic mud. My mentors are Professor Alexander Gorbenko and Professor Homar Bersena. This is my research overview poster. Well, why did I choose to research about milk? As we all know, milk is the first liquid food which we all consume. There are a variety of milk products, and there are many different kinds of milks. Everyone loves milk, but for this research, we'll be focusing on organic cow's milk. Why organic? Let's see. Looking at this graph, this is the graph of organic milk sales in the US alone from the years of 2008 to 2018. As you see, there's an increase in the sales, which means that organic milk is in demand. But what does it mean for a product to be organic? Two things: to grow that produce or that food without the use of any fertilizers or any antibiotics, and B, to use fair farming practices which will actually protect the producer, in our case, the cow. Let's look at the research now. So the purpose is to demonstrate a separation in a filtering method to obtain the casein, or also known as the milk protein, for further analysis. My research goal is to be able to identify the nutritional differences between organic versus conventional 2% milk samples. Both of the samples will be 2% of fat. The materials would be isopropyl alcohol 91%, distilled white vinegar, mild stirrer, and a microwave. For the system, MetaboAnalyst 5.0 and a Fourier transform infrared spectroscopy. This table represents all of my 4 trials which I did for the 2 kinds of samples. Over here, you can see my trial 4 and final unwashed casein. We can note that the organic one looks much more softer and easier to break apart or pull apart than the conventional one. Please keep this point in mind, we will come back to it later. Trial 1 is without the alcohol wash. Trial 2 was failed. The temperature was too high and hot for the milk. Trial 3 is in progress but with a higher volume of milk. You don't want that. Trial 4 is perfect. A special filtering tool was used for the organic milk filtration for better isolation for the casein. Samples are dried and grinded for further analysis and given to my professors, Bersena and Gorbenko. Using the FTIR, we generated this graph model using our 7 samples. The area around the 1700 to the 1500 centimeters are the carbonyl peaks, while the area around the 1500 to 400 are our fingerprint region. This region helps us to distinguish between the compounds between their samples. Moreover, the peaks are very intense, meaning much more up and down, due to my samples being dry, which leads to a greater sensitivity and noise to signal ratio. In general, in this spectrum, we see that the organic samples are much more intense, meaning much more down, than the conventional ones, except the dark blue sample number 3. This may be linking back to what I mentioned earlier about a conventional sample being very hard. It was very hard to grind it. Next, after doing this, we did the principal component analysis. For the scree plot, we can see that there's a clear difference in the variance number 1 and the variance number 2, giving us of a 93.1%, meaning that a 2D graph is possible. Next, using the score plot, we can see that the red is the conventional while the green are the organic samples. There is a clear difference between the compounds due to minimal to none overlap amongst the samples. This concludes that there is a difference, but the specific is not known yet. To conclude, the initial sensitivity we notice requires further differentiating analysis for the casein. 2. The using of the PCA analysis plots, we could notice major molecular compound differences. And 3. More analysis and tests are required for quantification regarding the molecular compounds. Lastly, these tests can be further carried for analysis. Thank you so much. I hope you liked it. Goodbye.